That copy. That copy.
System, sir, more system on it.
Who is the anchor? No announcement, nothing.
Sir,
ಯಾರು? ದೇವದಾಸನ?
I am there.
Good morning, sir.
Good morning. Are you able to see me? Is my
Yeah, I can
video
able to see. Yeah, I can able to see this, sir. I think
Okay.
audio is also fine, sir.
Audio. Okay. I have unmuted it. Should I mute it?
No issue, sir. We'll have a formal inauguration and then we'll start your session. Sir.
Okay.
Volume. Volume.
Satish. Government Satish. ಆ ಕ್ಯಾಮ್ರಾ ಹಂಗೆ ತೋರ್ಸಕ್ಕಾಗತ್ತಾ?
Rajkumar. Volume.
Hello. Yes. I'm audible. Good morning.
Good morning, sir.
Good morning. So welcome to everyone. It's given immense pleasure to extend everyone a warm welcome on behalf of Rajarashwar Group of Institutions. I'm audible, sir?
The audible, sir. You're audible.
Yes, sir, you are audible.
Yeah, it's given me immense pleasure to extend everyone a warm welcome on behalf of Rajarashwar Group of Institutions, Rajarashwar College of Engineering, who have clubbed all for us for the ACT Training and Learning Academy, an online FDP. Now, we would like to request all the dignitaries to join the for lighting the lamp on behalf of Saraswati.
Inauguration.
Satish. Yeah.
Recording.
Recording in progress.
Now I welcome Dr. C. Ramesh, Professor and Head of the Department of Mechanical Engineering, to enter the welcome address.
Ramesh.
Very good morning to all. Department of Mechanical Engineering, Rajarajeshwari College of Engineering, Bangalore, received the fund of rupees 93,000 to conduct this AICTE training and learning online FDP program, Lean Manufacturing in Industry 4.0 scenario. The FDP from today, 24th to 28th January 2022, I am happy to welcome you all in this online FDP. On behalf of our beloved chairman, Dr. A.C. Shanmugam sir, our vice chairman, Dr. ACS Arun Kumar sir, our Executive Director, Dr. S. Vijayanand sir, Chief Executive Officer, Sri C.N. Sitaram, IAS retired sir, our Special Officer, Dr. S. Jaibalan sir, our group of institution, with the support of our beloved principal, Dr. T. Chandrasekhar sir, our Dean R. Balakrishna sir, I welcome you all for this online FDP program. I take this opportunity to welcome all the speakers of this online FDP program. Also, I am happy to welcome the coordinators, Dr. Karthikeyan and Dr. Satish from Department of Mechanical Engineering, RRCE, and other faculty members supported for this FDP program. Last but not least, I am happy to welcome all the participants who have registered and attending this online FDP. May certainly this online FDP, Lean Manufacturing in Industry 4.0 scenario, will provide in-depth knowledge about the lean tools and the implementation. As a teaching faculty, it is time to upgrade our knowledge in various technologies, and it will help us to transform the same to our students. I wholeheartedly welcome you all for this online FDP program. Thank you, sir.
Now I welcome Dr. T. Chandrasekhar, Principal, Rajashri College of Engineering, to render the inaugural address.
So, good morning to one and all. So at the outset, I congratulate the Department of Mechanical Engineering for arranging this faculty development program. And also I thank AICTE for sponsoring this FDP program to enhance the knowledge of the faculty members to deliver, to meet the expectations of the industries. My humble request on this occasion is, we all know that there is a gap between the industry and the institute, which is a never-ending story. So we need to keep updating ourselves and meet the expectations of the problems of the day. It is not the problems of the industries, it is the problems of the day. So we are all requesting that, and also it is essential that the fastest is the buzzword everywhere. Everyone want everything to be in fastest mode. So the industry has been in an inevitable situation where they have to meet these fastest word to be in the sustainability situation. So on this occasion, I am happy that the department and the coordinator, Dr. Karthikeyan and Dr. Satish, have arranged a FDP program on lean manufacturing in Industry 4.0 scenario, which is the order of the day. And I request all the faculty members to please ensure that you will have a clarity of information for you to deliver and to take up the students to the best level. So I don't want to take much of your time. I hope these 5 days of FDP program is going to be an eye opener for everyone and every faculty members, which in turn are able to guide the students and equip the students to meet the challenges of the future. So on behalf of Rajarajeshwari College of Engineering, I thank all the resource people who have taken their time to share their experiences with the participants. At the same time, I request the participants to be very open and very interactive in taking the information and carrying forward to the student community. Wishing you all the best. Hope these 5 days of FDP will be very knowledgeable and meaningful. Thank you. Wishing you all the best.
Thank you, sir. Thank you for your address. Now, I welcome Dr. M. Karthikeyan, Professor, Department of Mechanical Engineering, and Coordinator for this FDP, online FDP, to share about the ATAL FDP.
Okay. Good morning to all. So, I wholeheartedly thanks to our management, principal, dean, and HOD for allowing me to apply for this online FDP and also to conduct the online FDP successfully in manner. So, I'm Dr. Karthikeyan. The 5 day schedule that we already discussed, already shared in the WhatsApp also and mail also. So, day one, the inauguration started now. So, first lecture given by the Dr. S.R. Devadasan about the fundamentals of lean manufacturing. Today, next session is what around 11 o'clock to 11:30. AACT share the link. So I request all the people will share the YouTube link already in the poster. So all of you again, I will share the link to all of you. So please all of you join because it is formally inaugurated by the AACT. AACT chairman and other members are attending and inaugurating this week FDP. This week all over India they started around 7 FDP. So we are also one of the members of this program. So after the first session, we will share this link. I request all the participants to join in this FDP. Second section given by the lean deployment in industry today with Dr. Murugarajan, HOD Professor Ramakrishnan Engineering College, Coimbatore. So he completed his PhD in IIT Chennai. So third session after the lunch, you can see lean manufacturing through the total productivity maintenance by N.M. Sivaraman, Dr. N.M. Sivaraman, Assistant Professor NIT Karakkal. So tomorrow program is lean tool implementation by the Vinod NIT Trichy. And next one is the Dr. Raju, Professor and Special Officer Evolution, Driver University, Bangalore. And the case studies on the lean manufacturing is very expert and also having 30 years of experience. So he is presently in Dubai. He has very good experience in the lean manufacturing and also ready to give the exposure about the case study. Third day, first session, Dr. S. Vinod. So he did the PhD and also gave the number of PhD students in the area of lean manufacturing in NIT Trichy. He is going to deliver the lecture on the lean manufacturing in the view of Industry 4.0. Next topic on the day 3, digital Kaizen and lean manufacturing. It is given by Dr. V.R. Prabodh, Associate Professor from Palakkad, Kerala. Next one is we are faculty who are in the stressful life, so we want to reducing the stress, how to manage the stress. It is a very good lecture that is planned on Wednesday, third session. It is given by the Rajiv Nambiar, Art of Living Bangalore, about the stress management. Day 4, nowadays all the industries moving towards the artificial intelligence and industry 4.0. So the topic artificial intelligence for manufacturing is given by Dr. Pramod Kumar SK Reva University, Bangalore. And also it is continuation the same day about the industry 4.0 through agile manufacturing by given by the VM Tilak, Associate Professor, Air Institute of Engineering Technology, Coimbatore. Last session on the day 4 is smart manufacturing by Dr. Magesh PM, who is from the JSC College of Engineering. Day 5 is the smart sensors of Industry 4.0 digital manufacturing is delivered by Dr. A. Murugarajan, Professor Ramakrishnan Engineering College. Next one is 2 experts because the industry could deliver because both of them are from the industry scenario. Day 5 on the second session, Dr. Mr. Ramprakash Kola, Managing Director, Distinctive Productive Solution. So he already given the training to our students also. So he's addressing about the industry 4.0. As related to the application of lean manufacturing industry by Nagaraj Jade. So he's a senior engineering in the Whirlpool India Pune. So last session of this FDP to the concluding with the voluntary function feedback session and also assessment test. We are planning as per the AFT now planning for 1 hour assessment test with 60 question executive type. That link will be shared on the last day of the last session. So this is about the brief introduction about the various session about the 5 days long online faculty development program on lean manufacturing industry 4.4 January. Thank you.
Thank you, sir. Thank you, Professor M. Karthikeyan, coordinator for this online FDP. Now, I would like to share some of the guidelines of the ATAL FDP. The following are the guidelines for the participant. Participants are strictly adhered to the following guidelines during the 5 days online FDP on lean manufacturing industry 4.0 scenario. The participants who have obtained attendance of 80% or more and also score more than 60% in the test will be issued a digital certificate by the ATAL FDP. And an online test will be conducted for the duration of 60 minutes on the last day of the FDP. And those who score more than 60% will be termed as a successful candidates. And the online sessions have to be recorded. Hence, all the participants are requested to present and interact with the speakers during each session. So all the participants, it is mandatory to give your valuable feedback at the end of each day. So thank you all. I thank Dr. Yeshi Shanmugam, and I thank S. Arun Kumar, Vice Chairman, and I thank Dr. S. Vijayanan, Executive Director, and also I thank Sri C. N. Sitaramu, sir, Chief Executive Director, RRGA, and I thank Dr. S. Jayabalan, Special Officer, RRGA. I thank Dr. Balakrishna, sir, the Dean, RRC, and also I thank Dr. T. Chandrasekhar, Principal, RRC, and I thank our beloved HOD, Dr. C. Ramesh, Department of Mechanical Engineering, and I thank Dr. M. Karthikeyan, the coordinator for this IDS ACT training and learning ATAL online faculty development program. I thank you all.
Good morning to all. Devadasan sir. Hello. Devadasan sir.
Yes, I'm here, Dr.
Sir,
Patil.
you're ready to share. Okay, so I will give the introduction, then you can continue the session. Okay,
Can
so
you share
first,
the screen from here, or you will?
you will share it now, sir.
I will
share it.
Okay.
You will please share it. So if there is any difficulty, then I will continue.
Oh, okay. Okay.
So I'll share the screen, sir. I will give you about the introduction.
Can you share now? Can you share?
Yes,
now?
sir. Yes, sir. Yes, sir. Please.
Okay. 1 minute. Let's be on the line.
Okay. Good morning, participants. So today lecture.
Dr. Karthik, are you able to see my screen?
No, sir.
No? Okay. I press to share. Share the screen, but still it's not coming. Just I look for.
Okay, so until start sharing, I'll give the introduction about the brief biodata about the Dr. S.R. Devadasan. So today's session is scheduled on first session, inauguration and fundamentals of lean manufacturing by Dr. S.R. Devadasan. Okay. So first session, inauguration and the fundamentals of lean manufacturing by Dr. S.R. Devadasan, Professor, PhD, College of Technology, Coimbatore. So S.R. Devadasan is currently held the post of Professor, Production Engineering Department of PhD, College of Technology, Coimbatore, India. He obtained his bachelor degree in Mechanical Engineering branch from the Government College of Technology, Coimbatore in the year 1986. He obtained his Master of Engineering degree in Industrial Engineering specialization from PhD, College of Technology, Coimbatore in the year 1989. He received his PhD degree for his work on strategic quality management from the same college in the year 1996. All these degrees were awarded to him by the Bardiyar University, Coimbatore. In the year 2008, Bardiyar University awarded him the postdoctoral degree, Doctor of Science, for his thesis titled Development of Strategic Quality Engineering Accounting System. He has 6 months of the industry experience and 30 years of teaching and research experience. He has served as the PhD worldwide sectional examiner for over more than 30 PhD scholars. He has delivered 130 special lectures and guest lectures. He has published over 220 papers in the proceedings of the leading national and international conference. He has published 160 research papers in UK-based international journals. Some of the journals in which his papers have appeared are International Journal of Quality and Reliability Management, International Journal of Operation and Production Management, Production Planning and Control, Journal of Quality and Maintenance Engineering and Benchmarking, an international journal, International Participation Empowerment at the International Journal on Managerial Auditing Journal, International Journal of Six Sigma and Competitive Advantage, and the TQ magazine. He is a fellow member of Indian Institution of Industrial Engineering. 25 research scholars have obtained his PhD degree under his guidance. So 4 research scholars are currently pursuing PhD programs under his guidance. He has delivered several technical lectures in various kinds of podiums to both the researchers and the practitioners. His area of research and interest includes strategic quality management, total productive maintenance, total productivity engineering and management, agile manufacturing, business process re-engineering, innovation management, supply side management, benchmarking, and Six Sigma program. He has a first authored the book titled Lean and Agile Manufacturing, Theoretical, Practical, and Research Futurities, which was published by the Printers of India Private Limited, New Delhi in the year 2012. And also I take this opportunity to welcome the Dr. S.R. Devadasan sir to present this topic on fundamentals of lean manufacturing. And also happy to inform all of you. So I'm Dr. Karthikeyan. I'm the first student of Dr. I feel proud to say I'm the first PhD doctor student of Dr. S.R. Devadasan. Now you can over the session to Dr. S.R. Devadasan. Sir, please continue, sir.
Thank you, Dr. Karthikeyan, for introducing me to the audience. Are you able to see my screen now?
Yes, sir, it is visible. It is visible, sir. Voice is audible.
It is visible. Huh? Are you able to see the first slide, the fundamentals?
Yes, sir. Yes, sir. Fundamentals of lean manufacturing. The slide is red in color. Your voice is also audible.
Audible. Okay, sir. Okay, sir. Thank you, Dr. Karthikeyan. Let me start.
Okay.
At the outset, sir, I am thankful to the organizers of this ATAL program, the management of Rajaraja Engineering College, the principal of Rajaraja Engineering College for granting me an opportunity to share some of my experiences as academicians and researchers on adopting the theory, implementing it, and expanding the lean manufacturing concepts. I presume that many of the participants would have been from different fields also. The participants who have been from industrial engineering field, they may be already knowing about lean manufacturing. And for them, okay, many of the concepts, okay, that I mentioned might have been already known to them. So in between, okay, I am under the impression that I can take the opportunity to interact with you. I would like to know whether, okay, you have already learned about these concepts. At the same time, okay, some of the participants friends, particularly those from fields like computer science, EC, and electrical electronics engineering, might not have been well exposed to lean manufacturing. But okay, the implementation of lean manufacturing now has to be carried out with the collaboration of all engineers. Today, this field has grown to this extent, and I congratulate the organizers of this program for identifying this development because okay, this program is aimed at imparting knowledge on implementing lean manufacturing through Industry 4.0. The implementation of Industry 4.0 cannot be carried out by the participation of only mechanical engineers. Okay, here, the participation of engineers from IT, computer science, okay, EC, and all these okay, fields are necessary. But before that, making such kind of implementation and achieve progression, it is necessary to have very good fundamental knowledge on lean manufacturing. Okay, have been given this particular task of imparting fundamentals about the lean manufacturing. Okay. So now, before going into the details of lean manufacturing, I would like to mention about the nature of the lean manufacturing itself. Okay, so it is actually a manufacturing paradigm. It is a style of manufacturing. It can't be said that it is a technique or tool. Okay, for example, we have all studied about engineering drawing. Okay, it is not like doing the engineering drawing, and okay, and also okay, we have all studied about various management techniques. Okay, so yeah, it is also not purely the practice of okay, implementing management subjects. It is nothing but the set of practices which create a type of manufacturing paradigm which will help the organizations. If the organization may be a manufacturing company or a software company or a service company like automobile servicing company to perform the job at appropriate pace with right quality and right quantity and without okay involving any waste. Okay, no, nothing okay will be wasted. Everything okay will be carried out without getting wasted. Now, okay, how did this manufacturing paradigm emerge in the world? Okay, in the ancient days, the craft production was practiced. That is when the man became the manufacturer by developing products like sharp weapons made of stones, and also man when man became the producer of say like ornaments and furniture, the craft production was followed. Okay. According to this system, only a single person or sometimes a few family members engaged in developing the products, and the production okay was very minimal in volume. Okay, in order to produce say yeah weapon made of stone which man would have used to kill animals, they would have taken about 1 week to produce that particular product. And from the days of industrial revolution, the humankind began to realize the importance of mass production. So mass production system developed, That means thousands of units of products okay, were produced from the days of the industrial revolution. So the engineers and managers are above that even the entire humankind were in search of the production practices which we call it as manufacturing paradigm to efficiently produce the products in mass. So because of that, the mass production system happened. So this mass production paradigm is still even today practiced. Okay, we are even in the educational field, we know that in olden days, the practice of Gurukulam was there, according to which the students had to stay with my teacher, and only few students were taught at a time. Okay, then the number of students got educated was less in number, and they were not finally given any formal recognition like the certificates, okay, that are issued today to indicate that, okay, that a particular student has successfully studied these principles. Then only after that concept of assembling under one roof in the form of schools, in the form of schools and colleges, the practice of imparting education to large number of students actually developed. So this kind of set of practices is collectively called as mass production paradigm. Okay. Now, then mass production paradigm was implemented in organizations from 19th century. All parts of the world began to adopt it. The reason was that this paradigm was the solution for facing for delivering large volume of products and enabling large number of people to assemble under one roof. The concept of one person or a few members of the family doing the work had to be dispensed with. So rather, the people of different origins, sometimes even from different geographical locations, had to assemble under one roof, and people had to do the work. Then other things, okay, like the specialization began to emerge out. So because of this, not one person did all the work. That person might do only design work, not all that person, okay, may carry out production type of work like that. Okay, the act of specialization began. Even division of labor happened. One group of people were identified as officers, the other group of people were identified as workers. Okay. And these practices, okay, are even today happening in the industrial environment. But from the middle part of the 20th century, the engineers and managers began to realize that when mass production is practiced, okay, it results in large quantity of overproduction at times. Sometimes, okay, it resulted in less quantity of the products, okay, that are actually wanted by the customers. Not only that, when the quality of the products were control, and only the same level of quality was prevailing. Suppose in a company, 20% of the pieces had to be rejected, then the same practice was going on. Okay, so and and the world began to accept okay, this phenomenon as the inevitable practices that emerged due to mass production system. Okay, so at that time only Japan faced severe competition. So Japanese companies had to produce high quality products with least price. Even today, we know that some of the products manufactured by Japanese companies are highly preferred by us. For example, if you take the case of calculators, we prefer cashew calculators, and those of mechanical field may be knowing. In the metrology lab, we prefer to use Meteota companies metrological instruments. So, in Toyota company, Japan, okay, they began to implement a system called the Kanban system. Okay, so they began to use the cards for indicating the required quantities and also with the specifications. So these cards were used when these cards reached the workstations. The operators had to use had to use only the required quantity, and that way, okay, the overproduction was actually avoided. So as you can see in the screen, okay, the fourth point, okay, there's two terms are there: push production and pull production. Okay, in the case of mass production, push production is done. So what is being done is the set quantity, the quantity of the product is actually manufactured. Then suppose, okay, 80% of the units produced could be sold, but remaining 20% could not be sold. Then this company will push those products into the market. How will they push this products to the market? Through advertisement and offering discounts, and also, okay, many other promotional activities, okay, will be followed to push the production. In the case of full production, the product will be pulled. So how is the product pulled? That is, it is based upon the demand uh, made by the customer. For example, in a laptop manufacturing company, a laptop with a particular specification is needed by 100 customers. So here, according to the system, only exactly 100 number of uh, laptops, okay, of that particular specification, okay, will be manufactured. So the number is pulled by means of the customer demand. So for this purpose, okay, they used a card to indicate the information that they call it as Kanban. Okay, so this is the way the full system originated in uh, Toyota company, and so all of a sudden the Toyota company and also many other companies in Japan began to produce products of high quality with low price. So the entire world actually looked at it very curiously. Okay, they very curiously looked at it, and then the professionals from various okay, parts of the world began to visit Tata Production Company and learn the practices, okay, that they follow. And finally, they began to call that particular practices as Toyota production system or just-in-time production. Okay, so this way the world began to adopt the full system, which ensured that only the right quantity of units of the products are produced at the right quality. And further, some authors began to study the tight operation system, and they refined that particular system, and they brought out the paradigm called lean manufacturing. Okay, so the origin of lean manufacturing lies on tight operation system or just-in-time production, and actually the term lean manufacturing was first used in one Harvard journal's article by one author by name Krapsik. Okay, that time it was not much recognized. The term was not much actually recognized. Okay, and only when three authors, okay, there's James Womack, Roos, and Staines. And these three authors brought out a book called The Machine That Changed the World. Okay, they brought out a book called The Machine That Changed the World, and they used the term lean manufacturing, okay, to indicate the refined form of tight operation system, and the lean manufacturing concept, okay, that they brought was encompassed with the core concept called waste elimination. Okay, that is the three authors indicated a very right perception. If an organization is able to eliminate the waste, then the organization has to keep on improve the quality, and the organization has to keep on trace the customers' requirement, and the organization has to keep on adopting new methods and technologies for improving its performance. At the same time, okay, it will ensure that only the right quality of products are produced. So what will happen is the waste of producing more quantity or waste of producing less quantity is actually avoided, and this benefit will be transferred to the customer in the form of the reduction of reduction of the prices. So as you see in the last screen, okay, this kind of approach is today required to be implemented in organizations to face the competition. We know that each and every day the competition is actually increasing, and in many situations the companies okay, go for price war. Okay, they keep on reducing the price. For example, in the field of jewelry, okay, and they keep on advertising saying that okay, they will charge no wastage, or they will charge only 2% wastage. Okay, and the normal practice of earlier was to charge 10% as the waste. Nowadays, okay, not a single jewelry shop okay, charges more than 5% of the waste. Because if they charge more than that, then customers okay, will go to another company in which case okay, the wastage charge will be very less. So, so the practices okay, leading to the uh, implementation of lean manufacturing will have to be studied, and we need to know from which end we have to start and what kind of output okay, finally we will achieve. Okay, there are companies by name A and B, so we should know that if the A company has to become lean manufacturing, what are the practices okay, they have to follow. Okay, if B company is already practicing lean manufacturing, and what will be the symptoms okay, that we'll be able to see in that particular company. These are all the aspects. Okay, we will try to we will learn and. During this coming a little more than 1 hour. Let me come to the okay, the next stream. Okay, as you see, okay, it is nothing but okay, the summary of what I have done. As you can see here, okay, and James Womack, Daniel Jones, and Daniel Roos. These are the three authors who worked further on chips, just-in-time manufacturing, okay, which occurred in Toyota company Japan, and they brought out the book in the year 1990 under the title "The Machine That Changed the World." Okay, the e-book is also available in World Wide Web, and I request, okay, all the
Sir, the other sir. The other sir. The other sir.
Sir, ask him to log out and log in once again. Many times Zoom gets hanged in between a lecture. So
Okay,
you're able
I'll
to...
call, yeah, I'll call him. I'll call him.
Right, sir. Right, sir. The screen gets visible, but the audio gets dumbed out.
volume of show मेरे में approved दिखा देंगे मैनेजमेंट लिखा हुआ
The other sir is audible. The other sir. The other sir. Okay, please, participants, please wait. I'll call him over mobile. Participant, please wait. I think you send internet got disconnected. So wait for a few minutes. So because I already shared the attendance link in the WhatsApp and also in the chat box. The request to all of you give the attendance. Because as per the ACT norms, you have to maintain the 80% attendance to eligible to get the certificate. And also, okay, so please all of you give the attendance. Every session will share the link in between or the end. And also you can share the link during the end of the session, end of the day.
Dear participants, sorry for the inconvenience. I think Dr. S.R. Devadasan will join shortly.
share screen. 1 minute. 1
Yeah,
minute.
that's it, sir.
Yes, okay. I have connected through my mobile.
Okay, sir. Okay, sir. Thank you.
Okay.
Yeah, slide is visible, sir.
Visible? Visible?
Yes, sir. Yes, sir. Visible. Yes, sir. Green color slide. That is according to the definition. The first
Yes, yes.
slide is visible, sir.
Okay, yeah. Earlier it was in our Wi-Fi. Now okay, through Wi-Fi. Our main mobile phone. Okay.
Okay, sir.
Okay.
Sure. Please continue. Please continue, sir.
Okay. So I'm audible also. I'm audible.
Yes, sir. Yes, sir. Yes, sir. Audible, sir. Audible.
Okay. Okay. Sorry, Pastor friends. Okay.
No problem, sir. It happened. Okay, please proceed, sir.
Unexpectedly. Okay. Okay. Anyway, okay. Many authors and researchers have brought out the definition of lean manufacturing. Okay, in essence, lean manufacturing refers to the set of activities that would enable the company to produce the products and services without incurring any waste or losses and ensuring that all the activities that are performed will be only useful. Okay, so what will happen is the quality of the products and the service will improve. On the other hand, the cost of production and the cost of offering service will go down. So this benefit can be transferred to the customer in the form of the price reduction. Okay, for example, if you can see two authors, Worley and Duran, have defined lean manufacturing as systematic removal of waste by all members of the organization from all areas of the value stream. Okay, the word value is highly used in the field of lean manufacturing, and value refers to the works against the cost. That is okay. We carry out the work, and if it is giving fruitful result, then we call it as the value. So the stages through which it progresses is referred to as the value stream in this particular field. Okay. Anyway, as you can see, the heart of the lean manufacturing lies on the elimination of waste in production environment, as well as in the environment in which services are offered. Okay, so certain terms and approaches have been utilized in this regard. Okay, to ensure that the right quantity of the products are produced and exact services actually provided. One term that is used is tag time. Okay, in the field of lean manufacturing, many Japanese terms are used, but this term is actually tagged. Okay, it's a term that that has come from German language. Okay, so the tag time refers to the rate at which a product is produced to meet the customer demand. Okay, so one example is also given. For example, customer has come out with a request for delivering 8 refrigerators at the end of the day. Okay, one shift is there, and it is of 8 hours active duration. So 8 refrigerators are to be ready. For example, this customer place order. The work actually gets started by 8 o'clock effectively. Then by 4 o'clock, it becomes 8 hours. By 4 o'clock, this customer will come to take delivery of these 8 refrigerators. Now, before starting the work, the company has to make all preliminary activities. It has to provide all the infrastructure and all training to the employees, and also about all the details. Okay. And also the facilities like tools, drawings, and so on. Okay. So now, okay. In this case, okay, by 8 o'clock the work gets started. So 8 hours are there, 8 pieces are to be there. So for every 1 hour, one refrigerator has to be produced. Okay, so that 1 hour is known as tag time, and this is different from cycle time. Okay, it is the total time taken to produce that particular product. Suppose, okay, in this company, the raw material is loaded, the employees have come, okay, the work is started by 8 o'clock. In between, there are some obstructions, and some waiting time is there. And so what happens is for every 1 hour 30 minutes, okay, one refrigerator is coming out. Then what will happen at the end of the day, that is before 4 o'clock, the customer will not be able to take the
Hello? Hello? Devadasan sir. Devadasan sir, please unmute sir. Devadasan sir.
Now, are you here?
Yes sir, audible now.
Is it audible now? Okay.
Sir, it is audible now.
Are you able to hear me now?
Yeah.
Okay.
Yes sir. Yes,
are you able to hear? Is it audible?
Yes, sir. It's audible, sir.
Audible. Okay. Am I audible to all of you?
Yes, sir. Audible, sir. Yes, sir. Audible, sir.
Yes. Okay.
Audible, sir.
So in that case, okay. Yes, sir. Okay, in in half a day, they will allot less number of facilities, less number of people, so that, okay, the 8 number of pieces will be ready only by 4 o'clock. Then the excess infrastructure and the resources will be utilized for carrying out some other activities or activities for producing the products and service. Okay, so this is one term. Then uh, uh, lean manufacturing, okay, lies on the elimination of waste. So what are regarded as waste? What about one waste? Okay, already mentioned, that is overproduction. Okay, that is okay. In the case of the mass production system, what happens is the operators come to the workplaces and they keep on producing the goods. And at the end of the day, customers may require 8 number of refrigerators. They may produce 10 number of refrigerators. So the remaining 2 refrigerators have to be sold in the market by applying push system. Okay, like advertisement through advertisement or offering discounts and so on. Okay, then other one is over processing. Okay, that is here. Certain processes are required. Okay, some process okay may be additional. Okay, for example, we may use the network system, and it may be required to check the entry of the data at one point of time. But in this company, they may be checking the entries at several places. Okay, so because of this, okay, the over processing of activities take place. Okay, that much effort will be wasted. In the case of manufacturing production, also sometimes, okay, uh, mm, in the case of mechanical field, the hardening has to be done at the end. Suppose, okay, by mistake they may make hardening in the beginning. So, okay, this will increase the number of processes to be to be applied for producing the components. So, if they make the uh, hardening at the end, and this may not be required. Okay, then comes okay delay. Okay, so the components okay reach a particular destination. Okay, but now the machine is not ready. The operators and not ready. Okay, and because of that, okay, the delay happens. The product has to be produced, say, 5 number of steps, step 1, 2, 4, like that. Step 1 is over, it comes to second step, but okay, it waits at the second stage to get it processed. Okay, then transportation. Okay, so in case okay, the facilities are kept far away. Then the semi-finished products okay have to be transported using manual or automated systems to a long distance. So this will actually elongate further the time of production. Okay, this also another waste. Okay, then inventory. Okay, so this is considered to be a major hurdle in uh, uh, producing the products with least cost of production. So when the work is going on, large amount of investment will be piled up. Okay, so now that much money is actually piled up in that. So it results in certain waste. Okay, then wasted motion. Okay, so the the FLT, it is the truck. The truck is actually made to move. Okay, which is not actually required. This motion is not required. If the components are kept nearby, okay, then that particular motion can be done. Or if the process plan is wrong, okay, then the motion will be more. That is known as wasted motion. Then defective parts. Okay, the process is um, 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 is having certain drawbacks or defects in that, and because of that, okay, defective products are often produced. Okay, so for example, in the field of mechanical engineering, when the process called broaching is used, and if it is tilted by just 1 degree, the entire set of formulas, which may be amounting to some 10 number of pieces, they will all get rejected. Okay, so likewise, in a component, 5 holes have to be drilled. So if they are drilled in wrong places, this will result in rejection. So what's the solution for that? We need to use the jigs, with foolproofing devices. Okay, a little time back I mentioned that many Japanese terms are used, in lean manufacturing because it has got the origin at the data person system. These ways are known as MUDA. Okay, in the coming lectures, very often the speakers will refer to this muras. So you may wonder how inventory, M refers to motion, W refers to waiting, O refers to work production, and D refers to defect. Okay, so these 7 ways were identified by Womack and the other 2 authors in their book titled "The Machine That Changed the World." Then apart from that, other authors also have identified many more ways. Okay, one ways that is identified in a book authored by Dennis Pascal is the knowledge disconnection. Okay, that is the operators and engineers learn new technologies and new practices, and when they are not given appropriate opportunity to implement then implement them. Okay, then they will then the knowledge will get wasted. Okay, so then likewise, another ways is identified by in our book, that is knowledge waste. Okay, that is the knowledge is actually wasted. Okay, they are not properly utilized. Okay, because the old practices are still being followed. Then what should be done to implement the lean manufacturing? Okay, so in order to understand that, we need to know the difference between the company in which mass production is followed and in this company lean manufacturing is not followed. Okay, the other company where lean manufacturing is followed. Suppose we go and stand in front of the shop floors of these 2 companies. Let me assume that in the first company, which I call it as A company, the lean mass production is followed. In the second company, which is called as B company, where lean manufacturing is followed. So in what way we will come to know that these practices are followed in these respective companies. When we stand in front of the A company, we will see everywhere a lot of inventory, and customers waiting for a long time to get the delivery of the entire consignment because only half of the consignments are ready, and many goods in semi-finished forms are moved here and there, and the people are also moved here and there, and they ask doubts with many people. So this kind of scenario we will will see in the case of the company in which mass production is followed and the lean production is not actually implemented. And the scene will be different in the B company wherein lean manufacturing is implemented. And here, okay, you can see the people do the work on their own. They won't refer to any other person, okay, because they will have all the information with them, and the status of the production also will be visualized by the engineers and supervisors by seeing the production, and that is known as visual management. Okay, and the entire shop floor will be free from any inventory. Okay, so only the pieces, okay, that are machined that will be in the machines, and once the machining is over, they will move to the next machine.
Sorry for the interruptions, sir.
Yes, madam.
Sir, we are not able to see the slides.
Yeah. You can join through YouTube, madam. The link already shared in the WhatsApp group.
It is visible now. 7 wastes are now discussing about 7 waste. Other participants, can you confirm slide is visible, please?
Yes, it's visible for us.
I have not pressed F5, otherwise
6 slide is visible only.
This slide are they able to see?
So it is visible, but
Are
it's
you able
not
to see
moving.
this
Only
slide
one
or
slide is
start?
there.
Devasan sir, you're discussing about
What
which
the
slide, sir?
Defective.
Devasan sir, please, which slide you are shown now?
Yeah, yes. 2.7 defective parts is titled as defective parts.
Sir, it's showing like 2.2
Above that,
processing
7
and
case
2.1 over
Lights
production.
are not visible, sir.
It is 2.2
Lights are
only
not
visible.
moving.
No,
Can you please move the slide down?
Now I'm moving. Now 2.3. Able to see 2.3? No. Are you able to see 2.3?
No, sir.
Okay, 1 second.
Okay.
Only showing 2.1 and 2.2, sir.
Okay, I will check. I have moved all these. Now are you seeing this in 2.3? Now I'm showing the first screen.
Devasan sir.
Are you able to see the first screen now?
Sir, Devasan sir.
Yes.
Sir, I will share it, sir. You can speak. Can you stop the sharing? Can you share it from my end?
What should I do now? Should I stop
No.
sharing?
Yeah, sir, please stop sharing, sir. I will share it.
No, what? Okay. Okay, now I have stopped sharing. Okay.
Participant, now the slide is visible. First slide.
Yes, sir, it's visible.
Yes,
Okay,
first
sir,
slide.
sir, which slide you want to continue, sir? Please tell me. I will share it. 2.7, no, sir. Defective parts.
Bring down. Yeah, defective parts. Okay, you can
Okay,
press
sir. Please
F5
proceed, sir.
to show the
I will control the slide. I will share it. Now,
okay.
participant 2.7 is
Okay.
visible. So sir will continue the 2.7 debate
Ah,
with
okay.
parts. Please, sir.
Will the person be able to interact if I ask one question? Dr. Karthie?
Yes, sir. You can raise the question. The participants can interact now.
Okay.
They can
So
unmute themselves.
can any of you tell the short form of the 7 ways I mentioned? I mentioned one short form to remember the 7 ways.
Participants, please interact with the speakers, please.
Okay. Any one of the speakers? You not remember the 7 ways. Okay. In literature world, experts use the word short form. Okay, on expansion of which we'll get the 7 ways. Do you remember I mentioned one term? Can any one of the participants tell that? Yes, Tim would. Okay, one participant has responded. Okay, Dhyaneshwaran, Mr. Dhyaneshwaran. Okay, thank you. Okay. Anyway, okay, more number of ways have also been identified by many researchers. Okay, then I was mentioning about the difference. Okay, we will see in the case of a company in which lean manufacturing is practiced and in the company in which only mass production is followed and not the lean manufacturing. Okay, so now right. So in the case of lean manufacturing, okay, there will be no inventory, okay, in the production environment, and only the pieces that are getting machined will be in the machine. And once they move, the piece in the next machine will also move to the next machine, okay. And people will not keep on interact with others. All the necessary infrastructure will be provided to the people concerned. So, so now the question arises, okay, whether it is totally a new paradigm. Okay? Lean manufacturing. Totally new paradigm. Okay?
So all the participants, please unmute.
Okay. So, is it the paradigm which started only in ATAL? Okay, so it is not exactly so. Okay, in fact, okay, the lean manufacturing practice was followed for many number of years, even before Toyota started to produce in one particular field. That field is nothing but the tailoring field. Okay, in the case of the tailor, when we go and place order for stitching the shirt. Okay, so we give the material to the tailor, and the tailor takes the entire measurement. Okay, then he will have to be very careful in seeing that okay, nothing is actually wasted. If it is wasted, okay, then you will not be able to stitch the shirt according to the specification that we require. Then each and every customer's body dimension will be different, and each and every order will be new order for the tailor. Then okay, now so once okay the customer comes, the chief tailor gathers all the data and he enters okay in the computer system, and that is taken as a printout. Okay, So that is actually nothing but the Kanban that I mentioned little time back. Okay, so this sheet is actually sent to different destinations. Okay, where people, where the assistant tailors are required to stitch. Okay, um, um, uh, shirt material. Some people have to stitch buttons. Some people have to stitch collars. Okay, so to those places it will go. They will refer to this particular sheet, and accordingly they will stitch. They will follow the specification given in that. So this itself, okay, is an example of lean manufacturing. But okay, why do we take a lot of strain to understand about lean manufacturing in engineering organizations? Okay, when it is already practiced in the tailoring system. Here, in the case of the engineering products, the products are somewhat different. They are not fragile. Okay, they are very heavy in nature, and the type of work that is done in these companies different, and we need to apply special techniques and special techniques, tools, and technologies, okay, for carrying out the work at a faster pace. In the case of tailoring, the product is actually fragile. The cloth material is very fragile. Okay, and that means okay, it is very flexible. Okay, handling will be easier. But in the case of the engineering products, okay, they are either very heavy or they are very micro sized. Say like in the case of the components used in speedometers or in watches, okay, they are very small nature. So the handling will be different. So we need to use certain specific techniques and tools for that. Not only that, when yeah, company in which mass production system is followed, when we have to implement them lean manufacturing, we need to follow certain steps. Okay, that also has to be carried out using certain tools and techniques. Okay, those tools and techniques, some of them are very unique to the lean manufacturing field. Some of them are applied in other fields also. Okay, that okay, we will be seeing in the next slide. From next slide onwards, for few slides, we will see this. So one is actually a total quality management. So we will try back. Okay, I mentioned that the quality of the product will keep improving in the lean manufacturing, and for this purpose, the total quality management has to be applied. So when total quality management is applied, the continuous improvement effort will be made. So today there will be 20% rejection. When TKM is applied, tomorrow it will become 10%, and it will slowly keep on improving, and in about 5 days or 6 days, okay, it will be like a zero defect manufacturing. There will be no rejection at all. Next slide, please. Next slide, please. Okay. Then comes okay. And the missionaries. Okay, so we were telling that the exact quantity of the goods that we manufacture. In case okay, the machines actually fail. So then the process okay will not be interruption free. Okay, there will be heavy interruption. Okay, then we cannot fulfill the customer's requirement. Little time back I was mentioning about tag time. So every 1 hour one refrigerator according to that example has to come out. So that is possible only if the machines okay, are well maintained. So for this purpose, while implementing lean manufacturing, the concept of total productive maintenance has to be applied. The effectiveness of these machines are measured according to this approach by a term called overall equipment effectiveness. Okay, according to this approach, the operators okay have to think that they are owning the machine, and they have to separate the problems okay and they have to see that okay the machines are running without any interruption. Next slide, please. Next slide, please. Okay, then okay, yet another Japanese term. Okay, it's a term used in Japanese language. Okay, then refers to continuous, K refers to improvement. Okay, now for a very long time, Japanese engineers and managers began to realize that the division of labor was very wide in the companies. In companies, as I mentioned a little time back, the employees are divided as officers and the operators. Now, the operators possess practical knowledge. Okay, the officers possess theoretical knowledge. The bridging of this was not happening. So, for this purpose, Japanese expert by name Ishikawa brought out the concept called quality circle. Okay, using this approach, when a particular problem or the task is taken, the employees, irrespective of the cadre, whether they belong to officer cadre or whether they belong to operator cadre, and those are associated with that particular task or problem solving effort, they will have to become the member. So that become that will become a quality circle. So in that quality circle, okay, they will have to discuss about the problem. They have to come out with the solutions, and the solutions have to be presented to the management. In many cases, what happened was after presenting the report, the management did not take much action. So for this purpose, while implementing Lean, the concept called Kaizen has been brought out. According to this approach, a team will be formed. Okay, it is different from quality factor. The team in this team, the employees, irrespective of the cadres, okay, will become the team members, and they'll be fully empowered to carry out the actions. They will involve in brainstorming sessions. That means, okay, they will have to be very creative, and they will have to analyze the problems or tasks to be done, and they have to come out with suggestions and solutions. Then the case team will be empowered to carry out the work. So they will implement the action. Okay, for example, when a software is being used, okay, there is a bug. Okay, and the software fails to work when certain data are fed. Okay, so now the case and team will work to find out the causes, and they'll come up with certain improvements and solutions which will overcome that particular so this kind of practice has to be implemented. That is lean manufacturing is practice. Next slide. Next slide. Next slide. Yeah, in fact, okay, I was mentioning about the Kanban. Okay, it is nothing but a card. In fact, okay, it can take various forms. Need not be card alone. When it is listed as a card, okay, it is very impressive, and that's the reason in Toyota they used Kanban cards. But actually, okay, as part of Industry 4.0, okay, we can use internet, we can use augmented reality, okay, and and also, okay, as I mentioned in the case of the Taylor example, a sheet of paper, okay, in which, okay, the details of the requirements are mentioned here. Okay, and so suppose, okay, a customer wants to stitch two pockets in the shirt. Okay, so that is actually mentioned in that sheet. So when it is sent to the assistant tailor, who is supposed to stitch the pocket, so he sees it, and then he stitches two pockets. Then when a customer wants only one pocket, so that is actually sent to the same auction trader, but he stitches only one pocket. So then in the case of the manufacturer, for example, it is the case of say producing say yeah. Uh, hmm, uh, uh, vacuum cleaner. So one type of vacuum cleaner is only for 10 customers. So they have to make only 10 number of pieces. So the number will be scanned. Next slide, please. Kanban card actually helps to ensure that full system is followed, then more production is also avoided. Then comes the uh, hmm, housekeeping. So now we need to ensure that that uh, hmm, uh, components, tools, and any other accessories that are required to be kept in one in appropriate places, and I mentioned that in the lean management, in the lean manufacturing environment, and operators on top of others. So it will be, and they'll go and find. So for this purpose, Japanese engineers brought a housekeeping technique under the name called Kaizen. It is in the Japanese equivalent of that is theory, state, resource, standardize, and sustain. One thing that all unwanted items are to be removed, and in particular order, they need to be kept, and so that uh, a standard procedure is followed to carry out the practice. For example, yeah, if there's a practice to keep that and drill this one particular place. The next operator comes, so he should not keep it in another place. It will be in a particular place, it will be kept in the same place only. Here again the question arises whether it is completely new, whether it is not of practice. Actually, it is practiced in certain environment where the retrievability plays a very important role. The best example is the library, in which the books are kept. We know that in the library the books need to be retrieved within the minimum possible time. So for this purpose, the racks are identified, and the UGC number, accession number are identified, and based upon that, we will be able to access the book. At the end of every year, the books, which have become very obsolescence. So they are actually condemnation. They are removed from the further consideration. Next slide, please. Next slide, please. Now, little time back I was telling, in the case of the lean manufacturing environment, only the piece or the unit that is required to be machine will be in the machine at any one point of time. So there will be no piece in between the subsequent machines. Then what will happen once this machining is over? So they will be very much synchronized in such a way that in one machine or in a set of machine, the time to be taken will be synchronized with the subsequent machines or set of machines which are kept in cells. For example, if there are, for simplicity sake, let me assume that 5 machines are kept in succession. So the processes will be synchronized in such a way that every machine consumes 15 minutes to machine components. So what will happen? Once the first piece is machine, then it will go to the second machine. by the time it goes to the second machine, the second piece will enter into the first piece. Then when the second piece is machined in the second machine, okay, then it will go to the third machine. So by the time the first piece will enter the first machine, the first machine, the second piece, okay, will go to the second piece. Okay, likewise, okay, it will happen. So at any point of time, if there is movement of the units or pieces, there will be one piece in between the machine. So this will be the scenario that is prevailing in the lean mass environment. So now the scheduling has to be done, okay, in such a way that the groups of machines are made together, so that, okay, in every cell, okay, equal amount of time is actually consumed. Next slide, please. Next slide, please. Okay, single minute exchange of time, SM EED. Okay, so here the efforts are made to reduce the time. Okay, in the field of mechanical engineering, we all know, those who belong to mechanical engineering will know that in the case of making a casting, okay, about 75% of the time is spent on developing the mold. Then only 10% of the time will be used for pouring the molten metal. Okay, then remaining 50% of the time it will be subject to petri. Okay, so the active process is only pouring the metal. Okay, so now the molds have to be prepared separately. Okay, they should not be done in sequence. They should be kept ready already. Say, for example, they can work in the night, they can prepare the mold, and the moment and it is ready by the morning. So immediately molten metal will be stored in it. So according to SMED, the activities will be classified as internal and external activities. The internal activities will have to be done in the machine, and the external activity has to be done separately. Okay, so that way the lead time of producing or the cycle time of producing the products can be reduced. Next slide, please. Okay, then comes the mistake proofing approach. Okay, so in the lean manufacturing environment, we know that the last letter D stands for defect. Okay, and the production of defective piece is required to be fully prevented. Okay, so when carbon is also used, there should be no defect. Okay, so I talked about Taylor, the example of Taylor stitching the shirt. The care has to be taken in such a way that no defect takes place. For example, when an assistant tailor is given with the Kanban, so that's nothing but a sheet of paper in which it is mentioned that 5 number of square shaped buttons are to be stitched. And by mistake, okay, he should not stitch round shaped buttons numbering 6. Okay, so this defect should be prevented. So now we have to see how that mistake is prevented from happening. Okay, so what's the solution for that? So in the case of a tailor example that I mentioned, we need to have the involvement of one more person. One more person has to up to which, and he has to take out the buttons as check, okay, it is correct like this, okay, he has to make it. And those who belong to mechanical like me may be knowing about the foolproofing principle used in jigs. Okay, in the case of the foolproofing technique, the when it is incorporated with the jig, so what will happen is the jig cannot be inserted in a wrong manner. Okay, it will go through certain slots in such a way that, okay, it is never inserted in wrong position. Okay, so now in the lean manufacturing, so every effort has to be taken to carry out this kind of mistake-proofing technique, and that is addressed in lean manufacturing field under the Japanese term called Pokayok. And this was actually brought out by an expert by name Shigyu Shingu. Okay, his uh, uh, books, okay, narrate the way of incorporating the Pokayok, and his books are somewhat written in a different manner. And in the first, okay, 50 pages there will be theory about Pokayok. Afterwards, okay, he has shown the existing system, and after implementing Pokayok, what a change okay has been made. Okay, so what preventive action has been taken. So likewise, okay, yes, in this book produced not less than 100 number of Pokayoks. So when we carry out the work in our workplaces, when we find that okay mistakes are happening very often, we should take the action in such a way that even if we forgetfully try to do the mistake, okay, the mistake has to be corrected. For example, we know that the checklists are provided when packing the goods. Okay, for example, when a fan manufacturer has to pack all the goods, okay, then the checklist has to be utilized by the packing operator. Okay, and only after he makes the tick and sign, okay, then it will be approved by the supervisor and subsequently to the engineers. So when the lean method is implemented, okay, every stage, okay, Poka yokes have to be made in such a way that the production of defective parts is actually prevented. Next slide, please. Next slide. Then, for a very long time, okay, the engineers, okay, were following different approaches. I said that by 1990, in the book, The Machine That Changed the World, lean manufacturing was introduced. Then, afterwards, for about 5 years, okay, engineers were following different approaches to carry out the lean manufacturing patterns. And the engineers and managers, even researchers, were not very sure of the distinct steps. What should be the first step? Okay, what should be the second step, and so on. So at that time, okay, one technique called value stream mapping. It was brought out way back by 1995. It is a very unique technique. Okay, that can be used for implementing lean manufacturing in organization. It may be a manufacturing organization or software manufacturing companies. Okay, so here it actually goes through 4 phases. In the first phase, the product has to be chosen. Sometimes okay, it may be a group of products. Okay, which may involve almost same stages of production. Then the activities that are currently taking place should be captured. So that is captured using uh, um, uh, uh, um, that is captured by drawing a map called current state map. That is okay, what is currently happening, that is map, and that map contains okay the features which are relevant to implementing lean manufacturing. Then after studying this current state map, we have to develop, suppose okay, we are implementing lean manufacturing, okay, we have to develop a new map which will show the modifications and improvements that are to be made for achieving the goals of the lean manufacturing. So what are the goals of the lean manufacturing? Okay, that is the production of products according to the exact quality, and the production of products according to the exact quantity that is required by the product. Okay, and then reduction of, and then cost reduction. Okay, achievement of the cost reduction, and then other benefits or other goals like timely delivery of the goods. These are all the goals of uh, lean manufacturing. So with that goal, with the purpose of achieving those goals, okay, some modifications and improvements that we made, and that had to be drawn by means of map by us. That is known as future state map. Okay, so it is something like our machine drawing or engineering drawing or civil drawing. Okay, suppose we have to build a house. Okay, so we express our preferences and we try to draw it. Okay, draw the
Devadasan, sir.
details, okay, of the okay, what? Okay,
Devadasan, sir.
Karthikeyan?
Karthikeyan here, sir. Actually, 11 o'clock ACT Inauguration is there, sir.
Okay.
Yes, sir. Can you please wind up within 5 minutes? Okay.
Okay.
Okay, thank you, sir. Thank you.
So now we see. Next slide, please. Quickly. Next slide, please. Next slide. Next slide, please. Okay. So this is the current state map. Okay, you can see some unique symbols are used in this case. Okay. Then this has been drawn by referring to the current practices that are followed. For example, this symbol refers to the number of operators. So only one symbol is there, means only one operator is there. Next slide, please. Next slide, please. In the next slide, okay, in previous slide, please. Previous slide. Okay, so here the modifications that we made, okay, they have been grouped together. Okay, instead of having 5 stations, the 2 cells have been created, and because of this, okay, the cycle time has been reduced. You can use those slides little later. You can see, because due to lack of time, I'm winding up. Okay, next slide, please. Next slide. Okay, it shows the steps that are to be followed to implement lean manufacturing paradigm in a company. Next slide, please. Next slide, please. Okay, so now, okay, so lean manufacturing forms the foundation for acquiring competitive strength. And now, thanks to the emergence of Industry 4.0, okay, we have many techniques. Okay, in the morning, principal mentioned about the roles, okay, that we all have to play. Okay, so we need to learn about okay, and those Industry 4.0 and the concept, and with that facility, we need to implement lean manufacturing and achieve the goals of the lean manufacturing. Next slide, please. Next slide, please. Okay, there is no time to get questions from audience. You can later on contact me through email if necessary. Next slide, please. Okay, then next slide, please. Next. Okay, so I just want to ask number of questions. There is no time for that. Okay, but only one question I would like to ask from this. Okay, so name the authors of the book in which the term lean manufacturing was introduced. Okay, you have to name the not only authors but also the name of the book. Can anyone of you respond to chat or Dr. Karthik, is there any facility available to enable the
Chat
participants
box
to
is enabled.
respond?
Chat box is enabled.
Okay.
They can unmute and speak, sir.
Okay, they can anyone of you can note the name of the book and also the brought out the term lean manufacturing. Dr. Karthikeyan,
Yes, sir.
it seems okay that there is some difficulty in responding. So let me please move the next slide also. Okay, some more questions are there. I thought of the next slide. Next slide, please.
Speaker can unmute now.
I thought of
Satya Prakash, you want to speak, no?
okay. What expand SMED? Can anyone of you expand SMED? Okay, it is 11 o'clock. Okay. Nobody's responding. It seems there's some problem. You bring it to thank you slide.
Yes,
Please
sir.
show the thank you.
Okay, sir.
Yes, okay. They are shown as responding. Yes, expanded SMED, single unit exchange of type. Okay, thank you. You can also try to answer the other questions okay, that have been given here because also it is exactly 11 o'clock. Let me complete it. Okay. It is very difficult to deal with fundamentals within 1.5 hours. Okay, but anyway, in a capsule I given, I hope the subsequent speakers will also throw light on fundamentals and then they will proceed. You will be able to capture the points exactly. Okay, and I wish all the participants to acquire knowledge on implementing lean manufacturing to Industry 4.0 through the subsequent steps. Okay, thank you very much.
Okay, sir. Thank you, sir. Thank you, Devadasan, sir. So, given the wonderful lecture on the fundamentals of lean manufacturing. So, what you said, it is correct. Within 2 hours, it's very difficult to cover the fundamentals of lean manufacturing, even though we get the information, basic information about various tools used in the lean manufacturing, such as a single minute exchange die, Pocoyoke, and value stream mapping, okay, and also various goals of lean manufacturing. And also last 2 slides, we discuss about the various questions and also road map for obtaining the lean manufacturing. So on behalf of all the participants and also my coordinator, Dr. Sadish sir, I thanks S.R. Devadasan for inspiring talk about the fundamentals of lean manufacturing. Thank you, sir. Any feedback from the participants? Any feedback? Okay. So I think next presentation, Dr. A. Murugarajan also join. Murugarajan?
Sir, I think my voice is audible, sir.
Yes, yes, audible. Okay, so that is at 11:45 will start because 11:30, 11 o'clock to 11:30 ACT.
Okay, so I'll join at 11. Just I want to check with whether.
Okay, yeah, I see in here. I'll make you as a host. You can share the screen and you can deliver the lecture.
Okay, sir. Okay, sir. Thank you, sir.
Okay, so thank you, Devadasan, sir. Thank you, participants. Okay, so let us join in the same Zoom link at 11:45. Before that, I share the WhatsApp group. I share the WebEx link for the ACT inaugural function. So I request all of you, because I think from the ACT, it is mandatory to join the session also. So all of you should please join in the WebEx link. Okay, so I will close the session now. Okay, sir, Devadasan sir, thank you, sir.
Thank you, sir.
Thank you. So we'll end the session. We'll join at around 11:45. So all of you please join at 11:40 shortly. Okay. So Devadasan sir, can I close?
Can I leave the meeting?
Yes, sir. Yes, sir. Thank you, sir. Thank you very much, sir.
Okay. Thank you for the opportunity. Thank you.
Thank you. Sadish, let us leave the meeting. Okay, thank you.